So this is really the last method we're going to learn about finding zeros. We've talked a little bit about what the purpose is of finding zeros. Does anyone remember what that is?
You can put it into a standard form.
Not necessarily so you can put it in standard form. Finds the x-intercepts when we graph it, because that's where we're going next, is graphing. So when we're finding zeros, we have a couple methods. The first method we reviewed was factoring. We would factor it and then set equal to 0 from there. That's one method of finding the zeros. What if you can't factor something?
Oh, you can't factor it? You just simplify it, so.
No.
You solve for it.
How?
You set it equal to 0.
And then what do you do?
Find the variable.
How?
By moving all the other terms over the set.
What if you can't?
You can.
You write non-factorable.
No, not factorable doesn't find zeros for me.
It depends on the equation.
Depends on the equation, yes. If it is a second degree equation, we can always use the quadratic formula. Remember that? Negative b plus or minus the square root of b squared minus 4ac all over 2a. That's always a possibility. And if neither of those work, now remember, within factoring, I should have mentioned this, within factoring we have sum and difference of cubes, we have difference of squares, we have grouping, we have snowflake, we have GCF, we have several different options within factoring. But if neither of those are going to work for us, keeping in mind quadratic formula can only be used in a degree 2 equation, our third option is using this thing called the rational root theorem. And this is really the last method we're going to talk about for finding roots. Okay, so let's figure out what this rational root theorem discusses. Now, I'm going to write what it is, but I'm not going to explain it right off the bat. I'm going to explain it once we get to our example, okay? So you're going to make fractions, and you're going to find the factors of the constant, and those will become the numerators of those fractions. And on the bottom, you're going to have factors of the leading coefficient. So that's what the rational root theorem tells us to do. So it's easiest for me to explain that if we actually get into a problem and do it. Okay? So I know some of you are still writing that, and that's fine. While you're writing that, I'm going to write down our first example. F of x equals x to the 4th plus 6x cubed plus 3x squared minus 26x minus 24. Okay, so when it says find all the zeros or the roots, my first thought should be, what is the degree? And in this case, our degree is what? 4th degree, which means how many zeros am I going to have? 4. So when it says find all the zeros, I'm looking for 4 answers. Make sense? Yes? No? Anybody? Okay. So I need 4 answers. And my first thought is, can I factor?
No, yes, no.
Well, it's not an x squared, and it doesn't have that pattern going on of the middle term being half of the first term, right? So I can't use snowflaking. It's obviously not a difference of squares, difference of cubes, sum of cubes. Can I use grouping? I can't use grouping because it's 5 terms, so I don't think I can use factoring. Can I use the quadratic formula? Why not? It's not a degree 2, which means I have to go to this rational root theorem. So let me explain the purpose of this fraction before I get into it. Here's how we're going to find a 0. We are going to put numbers into our box number. We're going to put the coefficients across the top, making sure that you fill in any placeholders that are necessary. And if I get a factor, what's going to happen? My remainder is going to be ideally 0. That's the factor, right? If it's not 0, then I have the wrong box number and I have to try again with another box number. So I could just start counting numbers through. I could try 1, see if it works, 2, see if it works, 3, see if it works. But that seems just kind of random guessing, doesn't it? So the rational root theorem helps our random guessing to be a little bit more intentional, okay? It's not perfect, but at least it gives us a starting place. So if I were to look at the constant of this equation, what is the constant of this equation? Do you remember what the constant was? That's the first day of notes in this class.
It was
Constant is the one that has no x, or that has x to the 0 technically. So in this case, our constant is negative 24. So if I took the factors of the constant, 24 is divisible by 1. We're going to put positive and negative in front of all of these because technically it can divide by both the positive and the negative nicely. Can it divide by positive and negative 2 nicely? 3, 4, 5, no, 6, 7, 8, I think there's only 2 more and I'm going to run out of room, 12, and 24. Yeah? What about the leading coefficient? What's my leading coefficient? 1. That makes life easy because the only possibility there is 1. Now you notice I wrote the theorem as a fraction. I need to take each of these constant factors and write them in a fraction over the leading coefficient factors. Now I can kind of ignore the plus and minus through this process. I just need to know that every one of my possibilities also has the plus or minus. So neither of these individually is my list of possibilities, but here is my list of my possible roots. I'm going to take the first number, which is 1, put it over 1. What is 1 over 1? 1. Next number, 2 over 1. What does that reduce to? 2. 3 over 1? 3. 4 over 1? 4. 6 over 1? 8 over 1? 12 over 1? And 24 over 1. When I have a leading coefficient of 1, it makes this list very quick to come up with. When it's not 1, we'll see what to do there. But instead of just guessing numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and working through there, this shows me where I should start. Now, obviously, 1 is on this list, so maybe that's a good place to start. So let's try 1 being on that. So let's start with 1 and see if we get that remainder of 0. So if I bring down this 1, 1 times 1 is what? 1. 6 and 1 is 7. 7 times 1 is 7. 3 and 7 is 10. 1 times 10 is 10. Negative 26 and 10. 1 times negative 16 is negative 16. I definitely do not get a remainder of 0, do I? So what does that mean? That means on my list of possibilities, 1 is no good. So now we move to our next option. Now you can pick any option you want to in there, but I personally like going in some kind of an organized fashion. So I'm going to try negative 1 next. Okay? So again, I have my coefficients, 1, 6, 3. Aren't we thankful for synthetic division? Can you imagine having to do this with long division?
Shoot, that's a lot.
Yep. All right, let's see if negative 1 gets us anywhere. Bring down the 1. Negative 1 times 1 is negative 1. And then I have 5. Negative 5. Negative 2. 2. Negative 24. Positive 24. 0. Yay! What did we just find?
0.
We just found one of our 4 answers. Do we have to do this 3 more times? Not necessarily. Don't freak out. But of my answers, I know that negative 1 is one of my 4 answers. Okay? I also know that by taking out the negative 1, I no longer have a 4th degree. I have a 3rd degree. X to the 3rd plus 5x squared minus 2x minus 24 is my equation now. Now that I'm down to an x to the 3rd, I can see if I can use grouping and cut off this process. Can I use grouping here? If I cut it in half, I have x squared and x plus 5 minus 2x plus 12. What? Does that work? No, so I can't use grouping, unfortunately. So what do I have to do? Keep working through my possibilities. So I'm going to cross off negative 1 because we already tested that. We're done testing the list, testing 1 and negative 1. So we would move on to 2. Now, something I may give you on a question like this, if this was a question on a test, this is kind of a long list of possibilities, right? This is 2, 4, 6, 8, 10, 12, 14, 16 numbers technically, right? I don't want to have to do synthetic division 16 times. That's just a waste of time, right? So I may give you a graph. Now, I know this graph is kind of hard to read, but it looks like my graph kind of goes down there. It's going to come up here. It's going to turn, come down here, and go up. And what did those zeros represent again? X-intercepts. Do you see the x-intercept of negative 1 that we already found? So if I can estimate another one of these x-intercepts, that's going to be the next box number I'm going to try. So if I look at this one, any guesses what that one might be? 2? How about we try 2 as our next box number? Because if it is crossing exactly at 2, I'm going to get a remainder of 0. Now, am I going to use the 1, 6, 3, negative 26, negative 24 from the beginning? No, I'm going to use the 3rd degree equation that I'm down to. 1, 5, negative 2, negative 24. Bring down a 1. 2 times 1 is 2. 5 and 2 is 7. 2 and 7 is 9. Did I do something wrong?
Yes. 2, 7,
Well,
14.
why do you use those ones?
Thank you. I have no idea why I put 9 there. So this is 12. Yeah? 2 times 12 is 24. And then 0. I'm like, why is this so far off? So guess what? I just found answer number 2. And I've taken my x to the 3rd down to what? X to the 2nd. So I have 1x to the 2nd plus 7x plus 12. Once I've reached x to the 2nd, I don't have to keep going through my list. Because once I've reached x to the 2nd, factoring is a lot easier and quadratic formula even will work. So to get my last 2 answers, let's see if we can snowflake this. What would the number on top be? 12. And the number on bottom, 7. What are 2 numbers that multiply to get 12 and add to get 7? 3 and 4. So this factors into x plus 3 and x minus 4. If I set those equal to 0, what does x plus 3 end up being? X equals, I'm sorry, x plus 4. What does x plus 3 end up equaling? Negative 3. And x plus 4 ends up equaling -4. So there's my remaining 2 answers. Okay? It's a long process, it is. Hopefully it's not super difficult because you understand, if you understand the process and why you have to do it, it's not as difficult, but it is a long process. There's no way around that. That's just the way we have it with some of these ones. Now, I would not give you on a test a 6th degree polynomial because that would just be a long, long process. We're going to probably hang out in the 3rd and 4th degree range looking for 3 and 4 answers because that's a little bit more reasonable. Okay? Questions? I saw a question. Yes?
Did you change the equation for the answers for the negative ones?
Say that one more time. Where are you talking about?
Like you put 1, 5, -2, -24.
I was using the answer I got when I had found a 0 the previous time.
So you would do that with everything.
So I took my 4th degree. Once I found a 0, I'm down to a 3rd degree equation. So that's what I use in my next step. And then I find a 2nd degree equation, and that's what I use in my next step. So you're continually trying to bring that degree down to an x squared because then you know what to do with an x squared. You can do something a little bit easier. Now, I want to show you something about this equation. Keep that equation in mind because we're going to go somewhere and look at something. If I go to your favorite website, oops, wrong one. You been to Desmos before? Well, you may not like it, but it's really helpful here. So if I do x to the 4th plus 6x to the 3rd plus 3x to the 2nd minus 26x minus 24, you can really see what that graph looks like. Yeah? And if I even just hover over here, it's going to give me those values really clearly. Now, I do need to see the synthetic division that backs that up as your answer. But see how a graph is helpful from picking answers off that list as opposed to having to just work through that list. If you don't have a graph, you just have to work through the list. But Desmos could be very helpful for you on your homework as far as once you come up with the list, what are you going to guess first? Okay? All right, so let's go back to here and move on to, what if I asked you on this one, what if I asked you, instead of find all the zeros, get that out of the way, what if I said write the factored form? It's easier than you think it is. Hmm? Okay. So if I asked you to write the factored form, here's my question. If -1 is an answer, what did it look like when it was in parentheses? Like if I got x equals -3, which is one of my answers, that's what it looked like in parentheses, right? If I got -1 as an answer, what would it look like in parentheses? Wouldn't it look like that? Because when you set this equal to 0, you get that as your answer. So what would +2 look like in parentheses? X minus 2. And the -3 and the -4, we know what it looked like in parentheses because we had it here. So it's x plus 3. And then if I gave myself enough room like I should have, it would be x plus 4. That's the factored form. So once factored form in zeros, once you have one or the other, it's really easy to go back and forth interchanging them. Okay? All right. Let's look at a little bit more. write the fully factored form here. Now, this one's kind of different because we actually could factor this using one of our methods. We could use grouping to factor this because when you break it down, it does work out nicely. But I'm going to use the non-grouping method just because you guys know how to use grouping. I'm going to show you how to do it if you can't. So I need to come up with my list of possible zeros. So I need my factors of the constant. Which one's my constant? 27. I like 27. It doesn't have a whole lot of factors. 27, I would have 1, 3, 9, and 27, right? That's not a ton. Then I find the factors of what? Leading coefficient. What's my leading coefficient? 1. I like that because there's only one possibility. So if I set up fractions 1 over 1, 3 over 1, 9 over 1, and 27 over 1, I come up with my list of possibles. So 1 over 1, that reduces to 1, or simplifies. 3 over 1 simplifies to 3. 9 over 1 simplifies to 9. And 27 over 1 simplifies to 27. So this list only has 2, 4, 6, 8 numbers on it. So hopefully I'll find one pretty quick. Now I don't have a graph to go from. I'm just going to go from scratch. So I'm going to start off with 1. I always start off with 1 and negative 1 because you should find an answer there pretty quick. So if I put the 1 there, what are my numbers across? 1, negative 1, 0, right? There's no x squared term. 27, negative 27. Let's see what we get. I have one of my answers, don't I? Now, is it asking for the zeros or is it asking for the factored form? Factored form. So if 1 is my answer, what did the parentheses look like originally? X minus 1 is an answer. Or x minus 1 is the parentheses, I should say. So f of x equals, that's the beginning of my answer. So? Now, I had x to the 4th, now I'm down to what? X to the 3rd plus 0x squared plus 0x plus 27. Do I need to continue down my list? Why? I have a sum of cubes. Don't I have a formula for factoring that? I'm not finding the zeros, I'm just factoring. So I can do my small parentheses, big parentheses. Same, opposite, always positive. Sorry, I'm squishing in here. What's the first parentheses going to be? X plus 3. And the next one? X squared minus 3x plus 9. There's my fully factored form. What if I asked you to find the zeros? What's the 0 here? 1. What's the 0 here? Negative 3. This represents 2 zeros. Can I factor that further? If I snowflake that, 9 and negative 3, I can't factor that further, can I? So what would I have to do there? Quadratic formula. What that means is on the graph, These two are nice x-intercepts. These two are ugly x-intercepts. They're at intercepts at some decimal that we don't know exactly. Okay? All right, last problem for today. I do have another one like the first problem I did, but I think I'm going to save it for tomorrow after you've gotten a chance to try some of this on your own and see where your questions are. But I do want to do one more with you. We're going to find the possible rational roots or rational zeros. So we're just coming up with the list of possibilities. So if f of x equals 4x to the third plus 3x squared minus 22x plus 8. I just want to come up with the list of possibilities. So I start off with what? The factors of what? The constant. What is the constant? 8. So let's see, plus and minus 1, plus and minus 2, 4, 8, right? Because 8's not divisible by 3, or 5, or 6, or 7. That's why I skipped those ones. You okay with that? What's next? Factors of the leading coefficient. My leading coefficient is what? 4. So I have 1, 2, not 3, and 4. What's different about this one? The leading coefficient does not just have a factor of 1. The other ones, it was always just a factor of 1. So we're going to see what this does to change our list. So our possible roots. We still have to set up our fractions. But do you notice that there's 3 options for denominators? We have to take them one at a time. So 1 over 1 is 1. That's on my list. 2 over 1 is 2. That's on my list. 4 over 1. 8 over 1. All right, I'm done with the 1. Now I have to put them all over 2. 1 over 2. And then 2 over 2. What does 2 over 2 become?
1.
It reduces to 1. Is 1 already on my list?
Yes.
So I don't need to add that to my list. It's already there. What about 4 over 2? That reduces to 2, which is also on my list, so I don't need to add it. 8 over 2. 4, which is also on my list. Okay, so I'm done with the 2's. That only added one new one because the other ones were all duplicates. Now I have to put them all over 4. 1 over 4, not on my list, so I do need to add it. 2 over 4, what does that reduce to? 1/2, which is on my list, so I don't need to add it. 4 over 4, 8 over 4,
2.
so that is my full list of possible roots. So having those extra numbers on the bottom causes you to have a couple fractional options. So that means is that you can have a fraction in your box number or as your box number. We try not to have a fraction as your box number too often, but we may see it here and there. Okay? All right, so I'm going to turn you loose in just a minute. I do want to go up to, let me open up our class. This posted while we were talking here. Please make sure to read the directions. You are only doing, do you see the directions up here on the top left? You are only doing 1 to 11 odd, and then 16 to 19 all, and number 21. What I've done is I cut and pasted the textbook so that you don't need to go through and scroll which problems you're doing. So on this first page, you just do the left column. That's your odds. On the second page, I cut out the problems you weren't doing. So here's 16, 17, 18, 19, and 21. So all of the second page, just the odds on the first page. If you do all of the first page, do not ask me for extra credit. I do not give extra credit for not reading the directions. You just get extra practice. Okay? All right. Happy studying.